Before I load the TF32 software that will be used to look at specific examples, I want to provide a brief tutorial on how to interpret the spectrograms. Displayed in the top panel are the spectrograms for the input test signal and the recorded output signal from a hearing aid with nonlinear frequency compression. Along the y-axis of the spectrogram we have frequency. Each line represents 1,000 Hz, 1,000, 2,000, 3,000, and so on. I added these tick labels to the display so you will not actually see them during the live program. The x-axis is really a time axis, but as you can see, the test signal progresses in frequency at a rate of 100 Hz per 100 milliseconds. So at 1 second, the test signal is centered around 1,000 Hz. At 2 seconds, it is centered around 2,000 Hz, and so on. This allows us to substitute time for the input frequency. So if we place the cursor here, we can see that on the y-axis, the input test signal is centered around 8,500 Hz. We can use the time readout in the upper left to get an estimate of the exact instantaneous input frequency, which reads 8,490 milliseconds, or about 8,500 Hz. The input signal is frequency modulated, therefore precision is limited to around 100 Hz. Using this information, we can see that for this hearing aid setting, that frequency lowering begins around 4,500 Hz. This is where the recorded output signal starts to diverge from the input test signal. We can also see that frequency lowering continues for input frequencies up to around 9,000 Hz, at which point these frequencies are being lowered to a little less than 6,000 Hz. Going back to where we placed our cursor, if we select Spectrum from the View menu, we see a display that is shown in the lower panel. This is the spectrum at the cursor time point. The y-axis is amplitude and the x-axis is frequency. Each division on the x-axis corresponds to 1,000 Hz, 1,000, 2,000, 3,000, so on. As before, I added these tick labels so you will not actually see them in the live program. Here we see two peaks. The input test signal frequency at 8,500 Hz or so, and the recorded hearing aid output frequency at 5,500 Hz. It's hard to see, but there is another cursor in the lower panel that I put on the first peak. The readout to the right indicates that the frequency of this peak is around 5,500 Hz. Above, this point in the spectrogram is shown by this horizontal bar along the cursor.